I first need to define what probability I'm trying to calculate. Right. So I am trying to calculate the probability that the gold is behind door number 2, conditioned on the event that the host, that the contestant chose door number 1, and that the host revealed trash behind door number 3.
Right.
Okay, so I'm trying to determine the probability that the gold is behind door number 2, assuming that the contestant chose door number 1 and the host opened door number 3, which revealed that there's trash behind door number 3. Okay, so this is equal to, by the definition of conditional probability, the joint probability divided by the probability of this event right here.
Right.
Okay, so now I need to figure out what quantities we had and how they fit into this.
Right.
So we know that this numerator here can be written like this. Okay.
Yeah.
Okay. So, based on what we previously discussed, we know that this conditional probability right here is equal to 1.
Right.
Right. So if the contestant chose door number 1 and the gold is behind door number 2, then the contestant has to open a door that reveals... thank you. The host has to open a door that reveals trash, and the host cannot obviously open the door that the contestant had already chosen. So there's only one possibility, and that's door number 3. So the probability of the host choosing door number 3 under this scenario is 1. So that simplifies things a lot. Okay, now we also talked about the fact that the contestant doesn't know where the gold is, and the gold doesn't know what the contestant is thinking. The gold, of course, is an inanimate object. And so, these two events are independent of each other.
Right.
And so this, in the numerator, this is just equal to the product of the marginal probabilities.
Right.
Okay, so now we can, by the definition of joint probability, we can rewrite this as P of H3 conditioned on C1 times P of C1. And now these two cancel, and we know that the probability of the gold being behind door number 2 is 1 over 3.
Yeah, it could be any one of the 3 doors.
Right. And if the host does not know where the gold is, and if the contestant has already chosen door number 1, the host has to choose one door randomly between the 2 remaining doors. The probability of that, as we talked about earlier, is 1 over 2.
Right.
And this gives us 2 over 3, which is the answer that we got using our first method. Okay. That is beautiful.
That's what I love about math.
Yeah. So, let's just review what we did. So, the contestant chose door number 1. The host opens door number 3 and reveals that there's trash. The contestant then needs to determine if switching is better than staying with door number 1.
Right.
So if they switch, they hope to get gold behind door number 2. Mm-hmm. So what is the probability of getting gold behind door number 2, assuming that these two things have already happened? So we can write this conditional probability in terms of this joint probability divided by this smaller joint probability. Then we rewrote this numerator like this, okay? And we know that this probability right here is equal to 1, because if the contestant opens door number 1 and the gold is behind door number 2, there's only one door that the host can open.
Yeah.
And that's door number 3. And so the probability of this is equal to 1. The contestant and the gold don't know what each other is thinking. And so this joint probability is just the product of the two marginals. This joint probability can be written as a product of this conditional probability and this marginal. And so this is equal to 1/3, this is equal to 1/2, and we divide these two and we get 2/3. Okay. All right, so that is, I think, a pretty elegant application of Bayes' theorem.
Again, what you're doing is you're using whatever prior knowledge that you have to inform whatever you're trying to figure out.
Right. Okay.
Yeah.
Okay. So that's pretty great. So Arnab, I really appreciate you coming on the central equilibrium again and showing how Bayes' theorem can be applied on to this slightly more complicated example this time. Yeah. Now, before we finish this episode, Arnab, do you have a book or a website or a blog or something that you've read recently that you really enjoy in math, science, or economics?
There's always a book I always like to go back to for reference, and it's one of my, I would say it's a book I really like back in undergraduate. It's Computational Statistics by Gibbons and Hoeting. Okay,
and I'll make sure to put the title of that book and the author's names in the video description down below. Okay. And if you're interested in learning more about statistics or chemistry or career development, you can always visit my blog, The Chemical Statistician. You can visit my YouTube channel to watch more tutorials on statistics and chemistry. You can watch more episodes of The Central Equilibrium on my blog or on my YouTube channel. And of course, you can always follow me on Twitter at ChemStatEric. Thank you for watching this episode, and I hope that you learned something useful today.